Bonding assignment number 1. The goal of this brief video is to be able to define a compound and recognize and interpret chemical formulas in order to create element inventories. Compounds. 2 or more different elements chemically combined. We defined compounds earlier in the year, and now we're really going to get to understand what that definition means as far as being chemically combined. They're going to gain, lose, share electrons, excuse me, in order to have that full stable outer shell. And in order to have that full stable outer shell, they're going to form compounds like the one in our example here, CuSO4, copper sulfate. That is a compound that forms. We had the original Statue of Liberty, and then sulfur and oxygen in the air reacting with that copper forms copper sulfate. And that's why the Statue of Liberty now looks like this. So compounds, when 2 or more elements are chemically combined. A chemical formula tells you what elements are in a compound and exactly how many of each. We have the compound H2O. H2O is water. There's 2 H's and 1 O in the formula for water. 2 H's, the symbol H stands for hydrogen, the symbol O stands for oxygen. H2O, there's 2 H's and 1 O. It's not written when there's nothing there. It is a 1. Please remember to fill in the note guide as we go through this. Formulas. A subscript written after an element symbol tells you how many of that atom are in the compound. And again, we just talked about H2O. There is H2O. The subscript 2 tells you that there's 2 H's. And when there's no subscript, when it's blank, there's a 1 there. So 1 O. And this is an element inventory, which is our goal of today, to be able to write element inventories. Again, if you haven't filled in that blank yet on your paper, H2O contains hydrogen and oxygen. And we're going to do an element inventory example now for the compound H2SO4. So how many hydrogen atoms are in H2SO4? That's sulfuric acid. There are 2 H's, right? The subscript 2 after it. How many S's? There's nothing written after the S, so it's a 1 S. How many oxygen atoms do we have? That 4 subscript goes with the oxygen, so 4. H2SO4 has 2 H's, 1 S, and 4 O atoms, or oxygen. So let's do some practice. The first one is SiO2. Element inventory for SiO2. Si, how many of them do you have? 1, because there's nothing written down there, so it's a 1. How many O's do you have? 2. So element inventory for SiO2 is Si1O2. What about MgOH2? This one's a little trickier. We got Mg, we got O, and we got H. Now let's try to figure out how many of each that we have. Mg has nothing written after it, so it's a 1. O has nothing written after it, but we got these parentheses, so let's blow this up a little bit. OH2. What those parentheses are telling you is that you've got 2 of everything in there. So everything in there is basically multiplied by 2. If we put 1's down here, then we've got 2 times that 1 gives us 2 O's, and 2 times that 1 gives us 2 H's. You've got 2 of everything inside the parentheses. Just for fun, I'm just going to write down another example. How about that H2SO4 we did earlier? SO4. If we change that compound and we put a 2 out here, what would our element inventory be? H equals S equals O equals H is still 2. This parentheses tells us that we've got 2 of everything in here. And remember that if there's nothing written after it, it's a 1. So 2 times our 1s would give us 2 of those. And we've got 2 inside the parentheses. We already have 4 O's, but we've got 2 of those 4 O's. So 2 times 4 would be 8 oxygen. So that's how the parentheses work. Back to your example problems. This one, C12, H22, O11. What about this one? CaO, CaO. Calcium is 1, oxygen is 1. How do you know when you have a new element? Anytime there's a capital letter, that's a new element. That's why you have to use those uppercase and lowercase letters correctly. C equals, H equals, O equals. Even though there's a bunch of letters in there, when you look at it carefully, you only have C, H's, and O's. So add them all together. We got 1 C here, and 1 C there is 2 C's. We got 3 H's plus another H is 4 H's. We've got those 2 O's right there. So 2. C2H4 O2 is the formula for acetic acid or vinegar. N2O. N equals 2. O equals 1. So I would like for you to try and pause the video now and do these last 3 and then turn it back on and see if you got them right. C2, C equals, H equals, O equals, C equals 2, H equals 5, plus one more here is 6, and O is 1, because there's nothing written down there, that's a 1. The next one, H2SO4, we already did. H has 2, S has 1, O has 4, and finally HCl, H has 1, Cl equals 1. So now, if you've just copied this down and you're probably listening to music on your earbuds instead of listening to me, those of you who have done that, you have no idea how to do this. So now you need to go back and actually listen to it and try to understand how to do element inventories. People that did this correctly the first time, you are ready to do the practice attached to the bottom of your paper. So you guys, if I can figure out how to get out of here, there is some practice attached to the bottom of your paper. We've been doing this paper. Come on. We just did those example problems, and now here you've got some practice. If you want to see how you're doing, you could do those first 2 examples and come have me check it if you would like. And again, there's always those 3 or 4 people that didn't really put their best effort into the video. I don't know why. And they get to the end of the video and they have no idea what they just did. You have to go back and watch the video again now. So do those first 2 examples, and if you want to have me check, well, the answers are there, I'm sorry. So you can do them, disregard the answers, and just try them on your own. If you're feeling good, okay. If at any point you want to come have me check these, you can do 1 or 2 and come have me check it. Show me this paper when you're done before you leave today. This is due today. Show me your element inventories for these 12.